Learn it fast, learn it smart, learn with us at SOFO. Subscribe now for more videos. Contact us for on-demand and regular tuition classes.
Welcome to Concept Videos from SOFO Learning. Today, let us take a good look at basic proportionality theorem in a triangle. Now, before we dive deep into this theorem, let us refresh some of the concepts involved. So, similarity between two shapes is defined by three criteria, one being equal number of sides, then corresponding angles are equal, and corresponding sides are proportional, or the ratio is equal. So if we have all these three criteria met for two shapes, then we know that they are similar. Now, what is the theorem, basic proportionality theorem? Look at this triangle ABC. We have two sides, AB and AC, right? So this side AB and this side AC. Now, the side BC and this line DE are parallel. So let's write that down. Side BC is parallel to the line DE. Now, if this is the given premise or the basic premise, then if that is accurate, then the theorem states that this side AB and side AC are divided proportionally. How do we show that proportion in a mathematical way? So the way to do that is the side AD. So from here to here, so that is AD divided by DB is equal to, so this is the proportion. Similarly, AE by EC. All right. So if these two lines are running in parallel in a triangle, then the sides are divided proportional for these two sides. AD by DB, AD by DB, that proportion is equal to AE by EC. I have created an exact replica of our triangle, example triangle here. So we've got ABC over here and the same rectangle ABC over here with the cross line DE parallel, running in parallel to BC. Now, what we are trying to prove is that this proportion AB by DB is equal to AE by EC, right? This is what we are trying to prove, and we know that these two sides are essentially parallel. Now, we're going to draw a line from this point E to this line in such a way that it is perpendicular over there to AB, and mark this line so that we can trace the outline of this triangle ABE. All right. Now, in a similar manner, let's draw a line that is perpendicular to AC from D, let's say like this, and let us mark this rectangle ADC over here. All right. Now let's call this point N and let's call this point M. All right. So what we know is that EN is perpendicular to AB and in this case DM is perpendicular to AC. Alright, now this EN, this length EN is the height of several triangles. So for example, ABE, ADE, and similarly we have this DM as the height of a couple of triangles ADC and ADE. Right? DM is the height of these rectangles. Now the core concept that we are going to apply here is the area of triangles. Now we will focus on this triangle ADE and ADE over here, and this triangle DEB and DEC over here. Our next step is to calculate the area of ADE. Alright, ADE, whose base is length AD and height is EN. Alright, so half EN times AD. Now let's calculate the same area ADE from here. Alright, ADE or AED from here is half times the base, which is AE, times this height DM. Right? Now both of them are equal, right? Because it is basically the same triangle. This is an exact replica of it, and the top portion is the same between each other. Now let's think about the area of BDE. BDE is equal to half times, so this the height is the same EN, all right, because this is perpendicular to the base, therefore EN is perpendicular to the base BD, and therefore you get the base BD times EN, and the area of this is DEC, right? DEC is equal to half times its height DM and the base EC. Alright, so let's do EC as the base times DM. Now, one of the key concepts here to make this proof happen is that this BDE area and DEC area are equal to each other. Why is that true? Because we know that these two lines, BC and this DE, are parallel. Alright, so the distance between these two lines is always equal. They will never meet. These two lines will never meet. They are parallel, and therefore the distance is always equal. Alright, now the area of these two triangles have the same base DE and the same height between these two lines. Alright, so the area BDE and the area DEC are going to be equal. Alright, same base, same height, therefore same area. Alright, now it's fairly easy to show the proportionality, because all we have to do is to take the proportion of the areas. Alright, so if we were to do area ADE AE divided by BDE, then this half and this half are the same. The EN and the EN are the same. So we get AD by BD. And over here, we've got this ADE by DEC. And what do we get? This half, no problem. They are the same. DM is the same, no problem. So we get AE by EC. Now, since this AD and this is equal, and this BDE and this DEC is equal, we just proved that because these two are parallel lines, the distance doesn't change and the base is the same, so these two triangles have the same area. Therefore, this is equal to, this ratio is equal. The areas are equal. Now the key term, having the other two being equal, the key term is AD by BD and AE by EC. And since these ratios, area ratios are equal, and therefore these side ratios have to be equal. So we have proved that these, if the lines are running in parallel, BC and DE are running in parallel, then they cut proportionally, and that is the proof of the theorem that we have studied. Okay, now let's try to prove the converse of the theorem that we just learned. Means if these two sides are proportional to the corresponding two sides over here, this line BC and this line DE are parallel. So let's write that down. All right, AD by DB and AE by EC. This is given. Then our point that we are proving is that BC is running parallel to DE. All right. Now let's imagine a point E star. Any point on this line AC, let's imagine this point E star away from E. And what we are going to try to prove is that E star and E are always going to be the same. And that's how we know that they are in parallel. All right. Now, the fundamental given point is that this point E is cutting in proportion to how AD and DB are working. So based on this, we know that AD by DB is equal to AE by EC, and that is also equal to, in the same proportion of AD by DB, we must have AE star by E star C. All right. Now the process is extremely simple. All we have to do is to add a 1 to both sides. Let me show you. So what we have here is AE, and we are going to add the rest to make it a full AC, right? So we will do EC by EC, and this is a 1. And we will do a similar approach. We will do E star C by E star C. And this is also 1, so the equation is balanced now. Now, this becomes AE plus EC, AE plus AEC. So the numerator is going to become AC. And over here, AE star till here and E star C is also going to become AC. So what is left at the bottom? EC and E star C. Now numerators are equal, therefore EC must be equal to E star C, and therefore E and E star are always going to be the same. That means that if they are proportional, these two lines are going to run in parallel. There you have it. That is the review of basic proportionality theorem and its converse. Thank you for watching.